This is section 8.3, part B, dot product and vector projections. Let u and v be non-zero vectors, and let vector w sub 1 and w sub 2 be components of vector u, such that w sub 1 is parallel to vector v, as shown. Then vector w sub 1 is called the vector projection of u onto v, denoted by the projection of u onto v in the notation. So what this means is we have two vectors. We have vector v, which is along the bottom here, and we have vector u. Now originally vector u is going in this direction, but what we want to do is we want to see what would happen if we take u and we break it into two components. One of the components is going to be parallel to vector v, and the other one will be perpendicular. So we're coming up with basically the x and the y components, but we don't know in what direction it's going to go because the first one has to be parallel to vector v itself. So we're going to break u into two different parts. One of the parts is going to lie on vector v, and the other one will be perpendicular to vector v. To find this, we're going to do u dot v over the magnitude of vector v squared, and whatever we get, we're going to times that by vector v itself. This would give us our projection of u onto v, or that's the same thing as saying this will tell us where vector w sub 1 is located. So we need to find the projection of u onto v. Then we're going to write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. So we're going to write u as w sub 1 plus w sub 2, where w sub 1 is that projection itself. So w sub 1 is the projection of u onto v. We know our formula for this is u dot v over the magnitude of vector v squared, and then we're just going to multiply it by vector v itself. So let's find u dot v first. Remember, for u dot v, you do a sub 1 times b sub 1, so 3 times 5, plus a sub 2 times b sub 2, or 2 times negative 5. This is going to give us 15 minus 10, so we know u dot v is equal to 5. We need to find the magnitude of vector v. Remember, when you find the magnitude, you just take your first coordinate squared plus your second coordinate squared. 5 squared is 25, 5 squared is 25. That's going to give me a radical 50. But we are going to use the magnitude squared. So if I square a square root, that's just going to give me 50. So if we plug these in, our u dot v is 5. Our magnitude squared is 50, and we're going to multiply it by vector v. Now we can simplify this and just call this 1/10. We're going to distribute that 1/10 to both components. 5 times 1/10 is 5 over 10. Negative 5 times 1/10 is negative 5 over 10. Or we can say w sub 1 is equal to 1/2 and negative 1/2. So the first thing it tells us to do is to find the projection of u onto v. W sub 1 is our projection. Now we need to write u as the sum of the two components. So we know vector u is equal to w sub 1 plus w sub 2. Vector u we know is 3, 2. We just found w sub 1 is 1/2 and negative 1/2. We need to find w sub 2. To do this, we're going to get the w sub 2 by itself, so we're going to subtract w sub 1 to the other side. So 3 minus 1/2. If we write 3 in halves, this will be 6 over 2 and negative 4 over 2. Six halves minus 1/2 is going to give me 5 halves. Negative 4 minus negative 1 is going to give us a negative 3 because that'll turn plus positive. So if we want to write u as the sum of those two vectors, then vector u will equal the vector of 1/2 and negative 1/2 added to the vector of 5 halves and negative 3 halves. So what we know is that we took u and we're going to break it into two different parts. One of those parts is going to be on this parallel to vector v, and the other one will be perpendicular. So this first part of the vector is parallel to vector v, the second one is perpendicular to it, and if we put those two together, their resultant vector would give us vector u. We're going to find another projection. We're going to find the projection of u onto v again, and we're going to write the sum of u as well. So again, we're going to start with that formula. So we know that the projection of u onto v is equal to our w sub 1. We know to find that we're going to do u dot v and divide it by the magnitude squared of vector v, and that whole quantity we will distribute and multiply to vector v itself. So again, we're going to start finding that u dot v. So we're going to do 4 times 2 and negative 3 times 6. 4 times 2 gives us 8 plus negative 18. So u dot v is going to be negative 10. We're going to find the magnitude of v. So we're going to do 2 squared plus 6 squared, or 4 plus 36, which gives us radical 40. But remember, we are squaring that quantity. So our u dot v was negative 10. The magnitude of v squared, magnitude is radical 40, then the magnitude squared is going to give us just 40. And we're going to multiply that by vector v itself. Now we can simplify this. This will be negative 1 over 4 times vector v. When we multiply, this is going to give us negative 2 over 4 and negative 6 over 4. Or we can simplify that and just get negative 1/2 and negative 3/2. So that is our projection of u onto v. So if we take vector u and we move it so it has two different components, the component that will be parallel to vector v would be that vector. Now we need to find vector u written as the components, two components added together. So remember, vector u is w sub 1 plus w sub 2. We know vector u is 4 and negative 3. We know vector w is negative 1/2, negative 3/2, and we need to find w sub 2. We're going to subtract vector w sub 1 to the other side. Since that has denominators of 2, we're going to go ahead and make the one on the left also have denominators of 2. Eight minus negative 1, that minus negative turns plus positive, so this is going to give us 9 over 2. Negative 6 minus negative 3, negative 6 plus 3 gives us negative 3, is equal to our w2. So if we want to write this as a sum, we know vector u is the sum of vector w sub 1 plus w sub 2, or we can write that as negative 1/2, negative 3/2, plus the vector of 9 over 2 and negative 3 over 2. Easy way to check that, if we add back together, 9 plus negative 1 is 8. 8 divided by 2 does give us the 4. Negative 3 plus negative 3 is negative 6. Negative 6 divided by 2 does give us our negative 3, so we did have the correct answer. If the vector u represents a force, then we need to project u onto v that represents the effects of force acting in the direction of v. So we have a 3,000-pound car sitting on a hill. It's inclined at a 30-degree angle as shown. Ignoring the force of friction, what force is required to keep the car from rolling down the hill? So the car itself, its weight and gravity is going to be pushing it backwards. We need to know how much force is going to be needed to hold it in place. So how much force do we need to have on the brakes? So in this case, instead of our u and v, we have the vectors f and v, where f represents the force of gravity on the car. So because the car weighs 3,000 pounds, our force is pushing that car straight down, the force of 3,000 pounds. So our vector f isn't going left or right any, gravity pushes straight down, and gravity is pushing it down 3,000 pounds. Since it's pushing it down, that is going to be a negative number. Now we want to project this so that it's parallel to vector v, so we can say of that 3,000-pound force, how much of it is pushing actually down, and how much of it is pushing that car down the hill or letting it roll down the hill. So we're going to project vector f onto vector v itself. So the next thing we need to do is find vector v. Vector v, if we write it in component form, is going to have an x component and a y component. To find the x component, we're going to take the magnitude and we're going to multiply it by the cosine of 30, because cosine goes with our x. Now, we don't know anything about vector v right now, so we're going to assume it's a unit vector, so its magnitude would be 1. So I'm going to do 1 times the cosine of 30. The y value, remember y goes with sine. Again, our unit vector has a length of 1, so it would be 1 times the sine of 30. So our vector v is going to have the components of radical 3 over 2 and 1/2. Now to project this, remember we are going to do f dot v over the magnitude of v squared times the vector v itself. Now remember, f dot v, we take the first component, so 0 times radical 3 over 2 plus negative 3,000 times 1/2. So our f dot v is going to be negative 1,500. The magnitude of vector v we actually already had. We said it was a unit vector and it has a magnitude or a length of 1. So the magnitude of vector v, we already said, was 1. So if we plug that in, u dot v is negative 1,500. And that's over the magnitude squared, which is going to give us 1. So that's going to give us negative 1,500 times vector v. Our goal in projecting this was just to see how much force was actually pushing the car down the hill. So since w sub 1, which is right here, has negative 1,500 pounds times vector v, then how much force will vector v have to keep the car up the hill? If there's negative 1,500 pounds pushing it down, to keep it up, you would need a positive 1,500 pounds of force. So the amount of force that would be needed to keep the car from rolling down the hill would be 1,500 pounds of force.